Morning students, I hope that the class edge video that you had just seen on the topic physical properties must have been beneficial to you. Students, before I start with my today's video demonstration lecture, let me share with you the learning outcomes. After the completion of the topic, the students will be able to compare and contrast metals and non-metals on the basis of their physical properties, define the terms ductility, sonoricity, thermal and electrical conductivity, demonstrate with an activity that metals are good thermal conductors. The first physical property is luster. Students, the term luster means shine. Metals have a luster. You have seen your parents wearing ornaments of gold and silver. They have a shine. The aluminium foil in which your mother wraps food is a metal and it has a shine. On the other hand, non-metals, they are dull in appearance except iodine which has a shine. Students, you can see in the picture that iodine has shine. The next physical property is ductility. Let us first define the term. The property due to which a metal can be drawn into thin wires is called as ductility. Metals are ductile in nature. It means they can be converted into wires. Gold is the most ductile metal. Aluminium, iron, copper are some examples of metals which are ductile. Students, this property of ductility finds its application in one or the other way in our daily lives. Let us find in which way this property finds its application. Students, you have seen a bulb at your place. If I ask you how does the bulb glow, you'll say, ma'am, it is so simple. We switch it on and the bulb glows. Okay. Do you know which physical property is involved? No? Let me answer it for you. The bulb has a metal wire. When I say metal wire, it means the metal is converted into wires. So which property now is involved? It is ductility. So the next time when you see a bulb glowing, you can easily name the physical property that is involved as ductility. Students, you can see the property of ductility in mesh doors also. Mesh doors are jali ke darwaze. You can see the mesh door at your place. In this also the metal is converted into wires. So you can tell your family members, your brothers, sisters about it. That the property involved in the mesh doors is ductility. Students, when an electrician comes to your place to install a fan, what does he do? He installs a fan, but what does he do? He connects the wire. When I'm using the word wire, it means the metal is being converted into the form of a wire. And in front of you, you can see a copper wire, which is ductile. So now I think my students can answer why copper is used for electrical fittings, because it is ductile in nature. On the other hand, non-metals are non-ductile. I pass on to the next property, that is sonoricity. Let us first define the term. The property due to which a metal produces sound when struck with something hard is called as sonoricity. Metals are sonorous, whereas non-metals are non-sonorous. Let us study in detail about sonoricity in metals. Metals are sonorous. Students, I hope you all believe in God. Yes? Okay, I also believe in God. We all go to church, temple, gurdwara or to a mosque to offer our prayers. Have you ever thought of that when you go to a temple and you ring a bell, you hear a sound, but do you know which physical property is involved? Can anyone tell me? Okay, let me answer it for you. Students, the bell in the temple is made up of a metal. The moment we strike it, it produces sound. So which physical property is involved there? Sonoricity. So the next time when you go to a temple, you can easily relate the property of sonoricity there. Students, I hope that you all are missing school. but we are still connected with technology and we are learning each day. Students, I'm going to ask you a question that how do you come to know that the 8th period has come to an end? You will say, ma'am, it is so simple. The bell rings and we come to know. Okay. But now can you tell me which physical property is involved? Yes, very good. The property of sonoricity is involved because the bell is made up of a metal and when it is struck with something hard, it produces sound. I pass on to the next property, that is electrical conductivity. Let us first define the term. It is the measure of the ease with which electric current flows through a material. Students, metals are good conductors of electricity as we have already learnt. You can see a copper wire. In the circuit above, the bulb is glowing because the copper wire is being used, which is a good conductor of electricity. On the other hand, non-metals are poor conductors or they are non-conductors of electricity, except graphite, which is used in batteries. I pass on to the last physical property, that is thermal conductivity. Let us first define the term. It is the ease with which heat, energy flows through a material. Metals are good thermal conductors, whereas non-metals are poor thermal conductors. Students, you should note here that metals are good thermal conductors, therefore they are used for making cooking utensils. You should know, students, that when you ask your mother to cook delicious food for you, she cooks it in a vessel, vessel which is made up of metal. And because it is a metal, therefore the food gets cooked. How it gets cooked, do you know? The heat transfers easily because it is a metal. So the next time when you see your mother cooking food in the kitchen, you can easily relate that which physical property is there? Thermal conductivity. Students, as you can see in front of you in the virtual chemistry lab, there is a silver bowl, there is a gold chain, there is a aluminium foil. All these are metals and metals have a luster. So we have discussed the property of luster. You can see in front of you there is a bowl and I have taken a spoon. You can hear the sound. Why? Because it is made up of a metal. You can see a bulb in front of you. It has got a metal wire. And which property it is exhibiting? Ductility. You can see a copper wire also. Which property it is exhibiting? Ductility. Students, you can see in front of you a cooking utensil which is already at your place also. It is made up of iron. And because it is made up of iron, the process or the physical property of thermal conductivity takes place. Students, I hope till here all the concepts, the physical properties that we have taken are clear to all of you. You will be provided with the activity sheet. Kindly complete that, which will facilitate in better learning. Thank you and have a nice day.